All right, so we are talking about compound inequalities. Now, in compound inequalities, a compound inequality is an inequality formed by joining two inequalities with the word and or. So with an and, the graph of a compound inequality with and is the intersection of the graphs of the inequalities. The graph shows the numbers that are solutions to both. So simple terms here, guys, is with and inequalities, both have to be true, so our graphs are going to be overlapping. All right, with or, it is the union of the graphs. So the graph shows numbers that are solutions of either inequality. Simple terms here, with or inequalities, our solutions must be true for at least one of the inequalities. So the graphs do not have to overlap. All right, so let's look at our first example here. Now, this is a and compound inequality. No, I do not have to do anything with this. I can work this out just as is. But I can also take it and take the middle and use this to write one, and then use this to write the other one. So as you see that there. So all right, so we're going to work these out. I'm going to start and work the one that I wrote over here on the right. So I'm going to solve this simple inequality I have here. And to do that, I would add 2 to both sides. So -4 plus 2 is a -2, less than x. And now I have to work the other one out. So same steps, add 2 to both sides, and I get x is less than 5. Now, remember we can, for graphing purposes, flip this so that x is greater than a -2. All right, I'm going to show you the other way now that we can solve this. Without splitting this into 2, I can still work this out. And I'm going to simplify the middle and work it out. So it's kind of like if I covered up the right side from the inequality over, and I would just have -4 less than x minus 2. And then I did the same thing with, so we still get -2 is less than x, which is less than 5. And those are saying the same thing, right? I got -2 is less than x, and x is less than 5. All right, so on our number line, what is this going to look like? All right, so I'm going to start by graphing this one right here. X is greater than a -2. So that tells me I have an open circle and I'm shading to the right because it's greater than. And then at 5, well, x is less than 5, right? So we're shading to the left. Now, if you remember in the previous slide, we talked about that we want the overlapping section. So where is my 2 graphs overlapping? Okay, well that is going to be right here in between. So that is what my graph is going to look like. I just took off the extra that I didn't need. And if we test this out, we're going to find that it's true. Okay, so test this out by checking. And I'm going to pick any number in between here. So we'll just go with 2. Okay, 2 is greater than a negative 2, isn't it? And 2 is less than 5. So that is true. And I could pick any number in between these two dots, and I'd have a true statement. Now, if I picked a number that was outside, like say negative 4, well, is negative 4 greater than a negative 2? No. So that automatically excludes that from being a solution. Sorry, that. All right, so let's look at our next example. I've got 2x plus 1 is less than 9, or negative 3x plus 4, minus 4 is less than or equal to negative 52. And so from here, I'm going to work both of these out. So I'm going to subtract 1 from both sides on this one, and I get 2x is less than 8 divided by 2. X is less than 4. And then I can work the second one out. Let's go with the pretty blue. So I'm going to add 4 to both sides. We get negative 3x is less than negative 48. Divide both sides by 3. Sorry, negative 3. And I get x is greater than or equal to 16. Now remember, when we multiply or divide by a negative, we have to flip the inequality sign. All right, so from here, I'm going to graph mine. So I have an open circle at 4, and I'm shading to the left. And then at 16, I have an open circle, and I'm shading to the right because it's greater than, sorry, not an open circle, a closed circle. It's greater than or equal to. Okay. Bless me. Ooh. All right, so let's go ahead and look at another example. This one is also going to be an and. Now, my preference is to just leave it as is and work it out. But remember from the first example, you can split it into the two. And I will show that one as well again here in a minute. So this time I'm going to start by minusing 1 to both sides, or say all 3 sides. So I get negative 3 minus 1 is a negative 4, less than. Okay, those become 0. So I'm left with 2x less than 4. Divide both sides by 2. And negative 2 is less than x, which is less than 2. So on my number line, this is an and statement. So remember, both have to be true. So I'm going to have open circles, and I'm going to be shading in between. Right? Negative 2 is greater, or x is greater than negative 2. And x is less than 2. So remember, with and, they both have to be true, or it is not a solution. All right, so if you guys want to see again, so remember with and, we can also write this twice. Okay, and work both of those out, and I'd come up with the same answers. All right, we're going to look at one last one for today, and this is another or. So again, I've got 2 inequalities. I'm going to work them out. So always undo addition, subtraction first. So 2x less than, so negative 2 minus 6 is a negative 8. Divide by 2. We get x is less than negative 4. Or add 5 to both sides. We have 4x is greater than 5 plus 3 is 8. X is greater than 2. So both of these have an open circle. So x is less than a -4, so I'm shading to the left. And x is greater than 2, so I'm shading to the right. All right, and that is it. Next time we'll be talking about absolute value inequality.